Welcome to Plutus Project-Based Learning 2023 from Gimbal Labs. Thank you for watching this video. We are currently working through Module 202, 5 Ways to Mint a Token, and this is the third way we will show you in this lesson. I can mint a Cardano native asset using Mesh APIs. In this video, we'll take a look at how to use the Mesh software development kit to build a minting transaction with a React-based front-end UI. In this course, we're taking a project-based approach to learning. So this is an example of how to build a minting transaction using Mesh, and we're not going to cover every single detail in this video. Instead, let's try to get this example working, which will give you a way to start playing around with different sorts of minting transactions. As we work through this example, I hope that you'll notice that there are many parallels between the approach we took in the previous video, minting native assets using Cardano CLI, and what we can do using Mesh in a React-based application. You can follow along with the documentation below this video. And just to get started, let's make sure that we have the PPBL 2023 front-end starter running locally. This is the same project that you first used in Module 201. I can change directories into the PPBL 2023 front-end starter. As always, the first thing I want to do is run git pull to make sure I have the latest changes. And I can also run yarn or npm install for good measure, just to make sure my packages are up to date. I happen to be using yarn in this example, but remember, you could also use npm run dev at this step. Then I can navigate to my browser to make sure this project is running. And it is. Now, this is the index page that we first used in Module 201. And I can navigate now to a new page called Minting. This is the one we'll use in this lesson. In my code editor, I can open up the repo, navigate to Source, Pages, and now in addition to seeing the index file that we used in Module 201, we can see the minting file that we're going to use today. And you could see for yourself, what's here matches what we can see right here. There's already a Connect Wallet button ready for you to use, and now we can work through the documentation right here. The first thing you'll see in this documentation is a bit of brain food. We didn't cover everything about native scripts in the previous lesson, so to help you continue learning more about what's possible with native scripts, you can read through these details and check it out. Here's another example of what a native script can look like. This one is a multi-sig minting policy that requires at least 2 out of these 3 signatures and must happen after a certain time. As always, we hope that you'll have some questions about this, and we can talk a lot more about multi-sig policies and advanced native scripts at live coding. For now, let's get to building. I already have the minting page open in my code editor. And the first thing we're going to do is find the pub key hash of your connected wallet. In the previous lesson, you saw how to use Cardano CLI to calculate the pub key hash of a public key file. Now you'll see that Mesh provides the exact same functionality directly from our React project. I'm just going to move back and forth between this documentation and add each of the lines shown here. Let's start with the imports. I have a couple of hooks from Mesh React. I have the use effect and use state hooks from React that we often use. And here's a Mesh function called resolve payment key hash. I can add all of these imports to the top of minting.tsx. And let's see, it looks like I'm using Mesh React twice. Let's take Cardano Wallet and place it inside of this import statement. That looks good. There we go. Next, I can initialize some hooks, the use address hook from Mesh and a use state hook that stores my pub key hash. These will go inside of our minting function, but they'll come before the return statement, which shows what's going to be displayed on the page. We can also create a use effect hook, which fires every time the connected address changes, and when there is an address, sets the pub key hash to the pub key hash of the associated address. We're using this built-in mesh function to calculate the pub key hash of the connected wallet. I can paste my use effect right here. This is pretty nice how this is set up. So now let's just add a little bit to what we'll see on the screen so we can make sure that the address and the pub key hash are showing up. Here's a nicely formatted box that we can take and place it directly inside of our return statement. I can find this comment that says start coding here on line 96, and I can paste this snippet. Now I'll save the file and navigate back to a browser to see if this works so far. Let's see. Well, I can see this new component, and it says my address is blank and my pub key hash is blank. But what if I connect a wallet? Cool. There's my address, and there's the pub key hash associated with it. Take a moment to compare what you're seeing right here with the approach we took in the previous lesson. As you can see, it's possible to create a pub key hash from Cardano CLI and also from a library like Mesh. Now that we know the wallet is connected correctly, let's build a form that allows us to take user input for the name of the token we will mint and the number of tokens we will mint. Once again, I can add an import like this. Then I can initialize the formic hook with this. We can put this above or below the use effect right here. I'll put it below. And finally, we can add this form to the UI. I'll place it below these two lines of text, but still inside of the new box we just created. Once again, I'll save the minting.tsx file, and I'll navigate back to my browser where I can see a nice little form that's ready to go. I can once again connect my wallet, and I can see that this form will allow me to copy and paste a pub key hash, say sandbox 3, and this time I'll mint 191 of these. Okay, but the mint button doesn't do anything yet. Let's jump back to the documentation. Finally, we can add some minting logic. Now I know that I'm already importing some tools from Mesh React and Mesh Core. So let me grab these import statements, look at the top of my file, and let's see. Use wallet, we've already got that, so I don't need this line right here. And it looks like we've got resolve payment key hash and then a bunch of new stuff here. Let me just grab this one, drop it into this import statement, and then I can get rid of this. And let's just organize a little bit so that the mesh imports are right next to each other. All right, that looks pretty good. Now I've got access to a bunch of functions I'm going to need to complete the next few steps. We can get our connected wallet from Mesh. I'll add this part right here. And then we can add a whole bunch of logic to this onSubmit function inside of the useFormic hook. To keep things simple, I'm going to copy this entire block that defines useFormic. It goes from here all the way down, looks like to here. So this closing parenthesis right here matches this one right here. I'll copy this, and then in the source code, I'm going to replace what was previously here for useFormic with everything I just copied. And that should be enough. I actually don't have to change anything that's visible on the page because the form was already built. So let's save this file. And let's see if this works. On the minting page, once again, I can connect a wallet. I can take the pub key hash I see right here. I can give it any token name I'd like. Let's make this one sandbox3. And once again, let's try to mint 191 of these. It could be any number. Now I'll click on mint. And this time, Eternal opens up and I have a transaction to sign. Let's look at the details. This is one of the best things about Eternal, is that it gives us very detailed transaction previews. I can see here that there is one mint or burn scheduled. It's a mint of 191 Sandbox3 tokens. I can also see that there's some metadata attached to this minting transaction. We'll talk more about this sort of metadata in the next module. I can see that this transaction requires one input, and I can also see that it creates two new outputs. One with most of the value from my input, and another with a min UTXO and the Sandbox3 tokens I'm minting right now. I can sign the transaction, and I can see a message that says 191 Sandbox3 tokens are minted. Congratulations. As always, this success message is going to precede the actual confirmation of this transaction on chain. So I'll have to wait a few moments to see these tokens in my wallet. And sure enough, I can see this new transaction, 191 Sandbox3 tokens. Not bad. Now, of course, this is just a demo. You'll probably have some questions about some of the logic you see here in the minting.tsx file. Try to read through this line by line and see what questions you have about how this works. In the lessons and modules to come, we're going to practice more building different kinds of transactions in a front end. I hope that this lesson has given you something to be curious about and that you'll bring your questions to live coding. Thank you for giving this project a try. I look forward to hearing your questions and see you soon.